Okay guys, so today we are doing the second half of our booklet together. We are finishing these notes up, and this is still on the same page. So yesterday we did intercepts, maximum and minimums, axis of symmetry, and end behavior. So today I want to look at intervals of increasing or decreasing and intervals of positive and negative, which are very similar, but I don't want you to get them confused. So for today, you do need two highlighters or two pens or two different colors, essentially, and we can get started. So intervals of increasing or decreasing is where we look at a graph and we read it from left to right, and we say basically what area of this graph is going down and what area of this graph is going up. And that area is that tiny little interval. And so we look at how it's moving up or down based on the y values, but it's described using the x values. So we know y values are these vertical values that move up and down. So if we were to look at this graph, reading it from left to right, from here it's going down, and then all of a sudden it flips and it starts going up, right? We're basing this up and down positive or increasing or decreasing intervals based on the y-axis. But we notate it based on these x-axis numbers. So I like to color. Basically, we cut the parabola in half. Whatever's happening on one half, the opposite should be happening on the other. So this half of the parabola is going down. It's decreasing. Once you get to that bottom, it starts to move up and it starts to increase. So one half is decreasing and the other half is increasing. And we use the x-axis to say, okay, what value stops this graph from decreasing to increasing? Where does that happen? And it happens at the vertex, which might either be the minimum or the maximum. And so that value is 3 on the x-axis, right? So if I wanted to say, okay, what interval is this graph decreasing? It's decreasing from this 3 up to here, but we don't know that that's where the graph stops. That's just where they stopped showing it to us. We know that this keeps going on for negative infinity. We just talked about end behavior, right? So if you were to move from your vertex over to this end to see what this end behavior is doing, you went to the left. So that's negative infinity. So the interval of decrease is from negative infinity, which is everything to the left, all the way up until 3. Right? So from negative infinity all the way up until 3, it is decreasing. I just wrote that in the increase part. So the decrease, I apologize, is from negative infinity to 3. Right? So from as far left as you could ever imagine, all the way down to this 3, it's decreasing. Once you hit 3, your graph starts to curve up and it starts to increase. So the values of, or the interval of it increasing is from 3 to positive infinity. Again, we use x-axis numbers. From 3, we move to the right to get to this end. So what's happening is it's going to use every x value to the right, which are positive values. So from 3 to positive infinity, it's increasing. Okay, so that means from 3 to the right forever, and this means from the left forever all the way until you get to 3. It's decreasing. So these are all going to be the same. They're cut in half like this. So I'll do this one right here, and then you guys will do these two as well. So I'm going to use the same colors as before. The left is actually increasing because this parabola opens up down. So I'm going up, 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 up. I'm increasing, and then all of a sudden, I'm now going down, 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 forever and ever. And the point that these two have a switch at occurs right here at, yet again, 3. So if I'm trying to figure out what this interval of increase is, well, we read this graph from left to right, then from this end, which keeps going on and on forever, all the way until we get to 3, we're increasing. Well, what is that end behavior? What does that mean? From the middle to this end, I'm going left. So that means my x values are values on the left. And we know anything to the left is negative. So it's increasing from negative infinity all the way up until it gets to 3. So from every negative value ever in the history of ever, if you started way back there, and then moved up until you got to 3, it would be increasing. As soon as you get to 3, your graph turns and it starts to decrease. From 3, this end behavior is positive infinity, right? From this vertex to this end, I went to the right, which means my x values are now going to the positive side. So from 3 to positive infinity, it is decreasing. So from 3 to positive infinity. And the reason that these are called positive and negative infinities instead of looking at them like yesterday's, well, we are looking at them like yesterday's, but yesterday I went from the vertex to the end behavior to figure out if it was negative infinity or positive infinity. And now what it seems like I'm doing is coming from the end to the middle, which is backwards from yesterday. But yesterday is finding the end behavior. You move from the middle to the end, and you say, okay, am I moving to the right or to the left? Am I moving up or am I moving down? And that'll help you figure out if it's negative or positive infinity on the x and y axis. But for intervals of increasing and decreasing, when you read a graph, you read left to right always. So we have to notate these from left to right. So if you still want to start in the middle and say, okay, which way does this end go and which way does this end go? You can do that to figure out if it's negative or positive infinity, but don't write it with 3 coming first every time or your center coming first every time. You have to write it from left to right. So yes, this end behavior is negative infinity and this end behavior is positive infinity, but I can't write 3 to negative infinity and 3 to positive infinity. See, I didn't write it like that. When you are graphing, we read from left to right. So when you write your coordinates, you have to write them that way. From the left is negative infinity, then 3 again, and positive infinity. So don't get that confused with yesterday's, even though it's using the same methods here. You guys are going to do these two on your own. Highlight them. Where are they decreasing or going down? And where are they increasing or moving up? And then, again, that's based on the y-axis. Like, where's this line going down and where's it going up? And then use these x values to tell you what that interval is. Interval of increase and interval of decrease. Same thing with this one. I want you guys to do that one. And then the second thing that I wanted to talk about today is intervals of positive and negative. A little bit different than what we just did a second ago with increasing and decreasing. Positive and negative is talking about x values when your y values are positive. And then x values when your y values are negative. So it cuts your graph in half in a different way. And I don't want us to get lost or confused on this either. So let's move slowly. Intervals of positive or negative. The interval of positive describes the x values for when the y values are positive. So let's look on this graph and say, where is the y value positive? Okay, well, if we know that the y values are up and down numbers, right? 0, 5, 10, these are y values. Well, all of these coordinates have positive y values, right? If I were to say, tell me the points that are on this graph up here, they would all have positive y values. Any of these points would have negative y values. This would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. These all have negative y values. So these are not part of the positive interval. Those are up here. We're not talking about decreasing or increasing. We're talking about the y values being positive. So right here is an interval of positive y values. And so the interval of positive, if we are looking based on the y-axis but notating based on the x-axis, we're going to say, okay, well,
this little tiny sliver based on the x-axis. Oops. Let me put a line there. Shouldn't have done that. Okay, well, we know that this graph goes on forever and ever and ever to negative infinity. It's going to the left there. So if negative infinity is where we start, this graph has values of positive y values until it gets to right here, which is 1 on the x-axis. So the interval of positive would be between negative infinity and 1, and then it picks back up right here at 5 and goes to positive infinity. Because between 1 and 5, it's in the negatives, so we can't include that. So then, if we were to say, okay, well, what are the intervals of negative? From here to here, all of these have negative y values. Every point on the graph, from here to here, these are all negative y values. Well, what is that interval on the x-axis? That is between 1 and 5. Between 1 and 5, you're going to get negative y values. So we look at it based on the y-axis, but we notate it based on the x-axis. And again, if you're looking at these end behaviors, if it opens upwards, that's positive. But if it's moving to the left, that's negative infinity. And if it's moving to the right or on the right side, that's positive infinity for those x values. I'll let you guys do this one. I will highlight it for you though. So the positive intervals are right here. All of the numbers on the line up here have positive y values. So what is that interval on the x-axis between what x value and what x value? And then the negative, the interval of negatives would be down here and down here. So again, from this point all the way forever, negative. And from this point all the way forever, positive. So how would we write that? Hint, 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 hint. Let's look at this one and do this one together. So as you can see, we're splitting our graph in half again, but this time we're splitting it in half above the x-axis and below the x-axis, whereas the page before, it was on the right side of the vertex and the left side of the vertex. And both times we use the x-axis to notate. We're just splitting it differently this time. So now, let's look at the positive interval and the negative interval. So what part of this graph has positive y values? What part has negative y values? And then find that point where it crosses over the axis. So the intervals of positive would be from negative infinity to negative 2, and from 4 to positive infinity. Remember, when you're looking at that end of your graph, if it's moving to the left forever and ever and ever, from the center, as you can see clearly, it's going to the left. It's also moving up. We're not talking about the y-axis movement. We're talking about x-axis movement. So every single one of these points is going further to the left than the point previous. That's negative infinity. Anything continuously kind of slanting and going to the right is positive infinity. So we have negative infinity to negative 2 and positive 4 to positive infinity. That's the intervals on the x-axis. Negative infinity to negative 2 and positive 4 to positive infinity. We cannot include anything between 2 and 4, or negative 2 and positive 4, because that is a negative interval. So the interval of negative would be between negative 2 and 4. Right where that one stopped and right where that one started. They stopped and started because they couldn't include any of this. All of this in the middle, between negative 2 and 4, is negative. So again, you'll do this one. I'll color it for you. This part between here and here is positive. From that point down to negative infinity, and from this part down to positive infinity. Now, even though this is opening down, I don't want you to think that that means it's negative for both sides. We're still talking about x values. The y values are majority negative, as you can see, because this opens down. But from the center, this end is further left, which is negative infinity. This end is further right, which is positive infinity on the x-axis. Like if this point followed it up, that's positive numbers on the x-axis. This point, it's negative numbers. So this is negative infinity and positive infinity. So just remember that we're looking based on the y-axis, but we're notating based on the x. So you guys will do these two for intervals of positive and negative, and these two for intervals of decrease or increase. Make sure that you're understanding how to do that, because next week we're going to put it all together. We're going to find x-intercepts and y-intercepts. We're going to find our vertex. We're going to find our maximum and minimum. We're going to find our axis of symmetry. We're going to look at those intervals of increasing, decreasing, positive, and negative, and look at our end behavior. So we're going to put everything together. So make sure that your notes are completed and that they make sense to you. And if you need to rewatch this video, please do. If you need to watch other videos on YouTube, just type in how to understand intervals of increasing and decreasing with quadratics, how to understand the axis of symmetry or end behavior with quadratics, and you'll find tons of stuff to help you. So make sure that you're getting this done so that we can complete our booklet next week. And that is all your notes for today.